How audio compression makes use of psychoacoustic masking. What we need to do is to think about the full range of human hearing. At its very widest, this is going to be from approximately 20 Hz all the way through to 20 kHz. So what we need to do is to break this full frequency range down into what we call critical bands. That is very small bands, all of which make up the total range of human hearing. We're going to look at the signals which are present within each of these critical bands and then assess each of these signals for their masking or their dominant capabilities. So it is within each of these bands that we are saying which frequencies are being rejected or which signals are being accepted as the dominant sounds. And then we're going to assess each of these sounds within each of these critical bands for the amount of bits that we're going to use for their coding. The dominant sounds are going to receive more bits for coding, and the masked sounds are going to receive less bits. Any signal adjacent to our original signal, which is strong enough and intense enough to break out of this envelope, will receive an appropriate number of bits to be encoded. Any signal which is within this envelope and is quite small will be either rejected or have very few bits allocated to it. This may mean that with quantization errors, those very small signals may actually generate some noise, and that is something that we need to think about in the encoding process. It may mean that towards the end of the process we have to go back and allocate some more bits just to reduce the noise on those masked signals.